Today we're going to review solving by graphing. And so to do this, I decided to do some quick notes on that just to make sure that everyone is refreshed and knows how to solve quadratic equations by graphing. So we're going to do this in standard form. So step 1, we're going to write the equation in standard form. So make sure that it's in standard form before you begin. And then step 2, you're going to graph the related function. So what that means, we're just going to take what we have up here. Since it's set equal to 0, we're going to write y equals ax squared plus bx plus c. So we're just rewriting it a little bit because when we graph, we always want to have f of x equals or y equals. And then step 3, we're going to find the x-intercepts if there are any. And then the solutions or the roots of the equation, those are the x-intercepts of the graph. So that's where it touches the x-axis. Okay, so as we're going through, I would write these down in your notes just to make sure that you understand what we're talking about as we're going through. And let's start with our first example. So solve x squared plus 2x equals 3 by graphing. And the first thing that we want to do is make sure that it's in standard form. So I'm going to rearrange this a little bit because right now I have x squared plus 2x equals 3 and I want to set it equal to 0. So to do that, I'm going to rewrite my equation. So x squared plus 2x equals 3. And since I just want this to be 0, I'm just going to subtract that 3 on both sides to get rid of that 3 on my right side. So I will get x squared plus 2x minus 3 equals 0. And now we're in standard form. We have an a value, a b value, and a c value. So now we're going to graph the related function. So to do this in standard form, we're going to set up a table. Here's my table. And before we start filling in values, we're going to find our axis of symmetry first, and then our vertex as well, because that'll help guide what values we want to put in our table. So I'm going to abbreviate this as AOS, so axis of symmetry. And the formula for this, again, when it's in standard form, is x equals negative b over 2a. So then let's find the axis of symmetry. So our b value here is 2. So x equals negative 2 over 2 times a. Our a value is 1. So our leading coefficient is 1 here. It doesn't look like we have a coefficient in front of x squared, but remember, if you don't see 1, it is 1. All right, so now when we evaluate this, we have negative 2 over 2 times 1. 2 times 1 is just 2, so we end up with negative 1. Okay, so this makes finding our vertex really simple because remember, our x value to our vertex is just the axis of symmetry. So we have negative 1 here. And then now to find our y value for the vertex, we just plug in this negative 1 into our original equation in order to find it. So hopefully, when you plugged it in, you found that your y value is negative 4. So now since we have these two things, we can go ahead and graph those. I'm also going to add them to my table because it's a point that we're putting on our graph. So remember, when we're looking at a graph like this, we're just going to say each one of these little squares is just 1 unit. So as I'm graphing this, I'm starting from the origin, going left 1 and down 4. So right here. And so that is our vertex. And we also know that this is our axis of symmetry. So I'm going to dash it just so we know that anything we put on one side, we can reflect onto the other side. So it makes our lives easier. Okay, so now I'm just going to choose points that are around my axis of symmetry. So one x value to the right is x equals 0. So I'm going to find what my y value is when x equals 0. So hopefully when you plugged it into your calculator, you got negative 3 for y. So let's plot that point. So 0, -3. And then because we have that axis of symmetry, we know we can reflect it onto the other side. So that should go there. And let's put that point on our table as well. So that's at point -2, -3. So we're not quite done yet because we don't know our x-intercepts. So we're going to keep going. The next point that we can do is when x is when x is 1. So let's do when x is 1 because we did x is 0 and now we're going to do x is 1. Okay? So when I plug that into my calculator, hopefully you get 0 for your y value. And so let's plot that point. So 1, 0, right there. Okay. Now, because we have that axis of symmetry, we can just reflect that point onto the other side and we'll get our last x-intercept. And that is at point -3, 0. So then now up here, it said our solutions or roots are the x-intercepts of the graph. So our x-intercepts are at -3 and 1. So the solutions are x equals -3 and x equals 1. Also, feel free to pause this video at any time if you need to catch up. And let's do our next example. Okay, so our next one is x squared minus 8x equals -16. And again, we're going to solve this by graphing. So we're going to write the equation first in standard form. That's step 1. So I'm rewriting my equation, x squared minus 8x equals -16. Now, in order to get a 0 on my right side, I'm going to add 16 to both sides. So I'll end up with x squared minus 8x plus 16 equals 0. And now it's in standard form. Okay, now we're just going to do the exact same thing that we did on the first example, and we're going to start graphing it. So when we're graphing it, though, we should always write y equals x squared minus 8x plus 16. And I actually don't believe I did that on this first example, so let's go back and do that as well. Needs to focus here. So we should have y equals x squared plus 2x minus 3. So make sure that you always do that so you know what you're graphing. That was my bad for not putting it on the first example, but let's continue with our second example. So we have y equals x squared minus 8x plus 16. And we're going to draw our table. So it's a t-table. Okay. And to guide our values, we're again going to do the axis of symmetry and the vertex. So to find our axis of symmetry, we have x equals -b over 2a. So our b value here is -8. So remember, if we have a negative in our formula, we need to make sure to keep that as we're plugging in values. So we have a negative on the outside, and then in parentheses, I'm going to put my -8 in, over 2 times 1. Remember, if you don't see 1, it is 1. Okay, so then we have negative times a -8. So +8 divided by 2, and we should get 4. So then our x value for our vertex is 4. And then in order to find our y value for our vertex, we would just plug in this 4 into the original equation and solve for y. And hopefully you got 0. Now I'm going to put this in my table and go ahead and plot it. So starting at the origin, 2, 3, 4, 0, and that's my vertex. And I also know that that's my axis of symmetry. So I'm going to draw this dashed line again so that I know what I am reflecting over. Okay, so now I'm going to choose one x value to the right, just like I did up top. And my x value to the right is 5. I'm going to plug that into my original equation, and hopefully you got 1 for your y value. So let's plot that point there. And then we know that we can reflect it over this axis of symmetry, so we'll have another point at 3, 1. All right, so this one is a little bit different because we've already hit our x-axis, so we don't really need to continue putting points into our table to graph more points. We can just kind of draw the rest of the quadratic from there because we already know our solution here. So if we were to find the x-intercepts, the only x-intercept is at the vertex, which is at 4, 0. So then therefore, the only solution that we'll have is x equals 4. All right, so hopefully this was some good review of solving quadratic equations by graphing. Please let me know if you have any questions for over these notes. We're always happy to help.